Welcome to Xamarin University. This is Xamarin.120 Introduction to Xamarin.Forms. My name is René and I will be your instructor here for this class. Our primary objective for this class today is to introduce you to cross-platform development, and we will use Xamarin.Forms for that. The idea of Xamarin.Forms is that you will no longer only be able to share your business logic across all platforms, but you will also share your UI interface across iOS, Android, and Windows Phone. To start out with, let's review how we managed the cross-platform UI approach with Xamarin in a more traditional way before we move over to Xamarin.Forms. In what we call traditional approach with Xamarin, we create one project per platform. So that means we have in our solution one project for Android, one for iOS, and one for Windows Phone. And for each of these platforms, we implement the UI. So we have different APIs. For Android, we use the designer, we create XML files. On iOS, we use UIKit, maybe we use storyboards in the designer. And on Windows, we will probably use XAML to create our UI. Now, even though the APIs are different for all platforms, it's still all C# if we use Xamarin. So what we can do is we can create a big portion of our app that will be shared across all platforms. And we put this either into a portable class library or into a shared project. Now let's compare this to Xamarin.Forms. And what you should notice here is that we still have all of our three platforms here at the top. We still have Android, we still have our iOS device, and we still have Windows Phone. And we also still have these little boxes that represent the platform. So we still have the green box, the purple, and the blue one. These are not just there to indicate that we will run on these platforms. No, they are really there for a purpose. These boxes show us that even with the Xamarin.Forms, there will still be platform-specific projects, and there will still be a bit of platform-specific code. However, most of the time, if you use Xamarin.Forms, the idea is that we do not have to touch that code anymore. On the other end, we still have our shared application logic, which will still be a big piece of our complete application. What's new, however, is a layer in between. We now have a shared UI layer. This is an abstraction of the UI that will work on Android, iOS, on Windows Phone. So the idea behind this is that instead of creating a button widget on Android, or a UI button on iOS, or a XAML button on Windows Phone, we will now simply create an instance of a button, and this button is a Xamarin.Forms button. And at runtime, this abstract Xamarin.Forms button will translate into an Android button widget, into a UI button on iOS, and into a Windows Phone button if it's running on the Windows Phone platform. So if we compare these two approaches, we will get approximately 75% of code reuse with the traditional approach, and we will get at least 90% of shared code with the Xamarin.Forms approach. Let's have a closer look at Xamarin.Forms. Xamarin.Forms is a cross-platform UI framework, and it supports Android version 4.0 and above, iOS starting with version 6.1, and Windows Phone starting with version 8. Xamarin.Forms comes with a set of standard controls that you probably all know. This includes simple things like buttons or labels, but also more sophisticated controls like list views that can also be templated. Since an application does not only consist of one screen with a couple of controls on it, we need some way to support multi-screen applications. And to do that, Xamarin.Forms has built-in navigation mechanisms that you can use. In order to arrange your controls on the screen, XamarinForms offers a very flexible layout system. We're going to talk about the different layouts that are available later. If you're not happy with the default controls that are included in XamarinForms, you can always go ahead and customize them. And if customization is not enough for you, you can create new ones. In addition, there's a component that you can add to your app that will add mapping support. Then you will have cross-platform mapping for all your target platforms. And one of the coolest things about XamarinForms is probably shown here in the last row. XamarinForms has full XAML support. That means instead of creating your UI in the code, which you can still do, you can alternatively use XAML. And XAML makes most sense if we use data binding with it. And XamarinForms also supports this. We have complete data binding there, and we also have styles and triggers available in the latest versions. At Xamarin University, we have additional classes that will cover XAML, data binding, styles and triggers, MVVM, and so on. Be sure to attend these classes. Today, we will focus on the basic concepts. You might say, wow, that's great. So I'm gonna use XamarinForms for everything from now on. XamarinForms is suitable for all types of apps, but not if your application will be highly customized. The idea of XamarinForms is that it uses the standard features of each platform. Now, if you write an iOS application and you want that iOS application to look completely like a Windows app, you would invest a lot of time customizing the look and feel of your app. And in that case, XamarinForms won't save you any time. So if this is your intention, a completely customized app, then you're better off using the traditional Xamarin approach. However, if your app is data-driven or is some kind of tool or utility app, then totally go ahead and use XamarinForms. Some great examples like LinkedIn could totally be done with XamarinForms. The Twitter application, XamarinForms, or Dropbox, also perfect candidate for XamarinForms. So as long as it's not completely customized, then XamarinForms hits the sweet spot. There's also another use case for XamarinForms. Even though you might consider using the traditional Xamarin approach in your final product, you can still use XamarinForms for quick prototyping. So if your boss asks you, can we do this and that on iOS or on Android? And you don't really want to focus on implementing the UI now for each of these platforms. Just go ahead, create your app with XamarinForms, put all your shared code into a portable class library, and quickly have something ready that you can present, saying, look, here we run on iOS, on Windows Phone, and Android. That will make your life much, much easier. Now we want to have a look at the different projects and the application structure of a XamarinForms app. Our goals here are to create a new XamarinForms project based on a template. And then we'll get a high-level overview of all the pieces that are generated by the template. And we want to also understand how it is constructed, how the platform-specific projects connect to the platform-independent parts. It all starts with a template. If you create a new project either in Xamarin Studio or in Visual Studio, you will find the XamarinForms application templates in the Mobile Apps section. In there, you'll find 3 templates. The first one creates a XamarinForms application that is based on a portable class library. The second one creates a XamarinForms application where the shared code will be in a shared project. And the third one is a library project. That creates a shareable portable class library, and that library has references to Xamarin.Forms, and it also can contain shared logic. The intention of this is that you add it to an existing Xamarin.Forms project. Please note that if you proceed with either of these templates, that if you run on Visual Studio, you will get a project for iOS, for Android, and for Windows Phone. If you use Xamarin Studio on the Mac, you will get an iOS and an Android project, but no Windows Phone, because Windows Phone development is not supported on the Mac. And if you use Xamarin Studio on Windows, you will only get an Android project. But don't worry, you can always add the missing projects later. The solution files are all fully compatible, so you can open them in Visual Studio, in Xamarin Studio on each platform. And if you decide later to switch over to Visual Studio and you want to add the Windows Phone project, then this is really easy to do. So depending on the IDE, we will get either 2, 3, or 4 projects in our solution. The first one, this is our portable class library. In that library, we have all of our shared code, our business logic, but it also includes the Xamarin.Forms UI code. In here, we will spend 99% of our time, and we will also place almost 100% of our code. And then we have the platform-specific projects. Remember, Xamarin.Forms still creates platform-specific applications. And that means we will have one project per platform. In this case, the Xamarin.Forms application was generated in Visual Studio, so we have one project for Android, one for iOS, and one for Windows Phone. By default, these specific projects, they act as hosts. And they have a bit of platform-specific code, but the idea is that they simply connect and talk to the Xamarin.Forms library. If we have a closer look at the portable class library, our Xamarin.Forms library, then this is where we'll place our business logic and our UI. There is one single C# file in there by default, and this C# file has one screen, and that screen is kind of the Hello World example of Xamarin.Forms. So it will only show a label, and we're going to see later what that looks like. We will later have a closer look at the code that is used to generate screens in Xamarin.Forms. And screens are defined by pages, and pages contain views. Each page is a screen full of content that will be displayed in your application. And that screen is called a page. On that page, we place our UI controls. The page class is abstract in Xamarin.Forms. We will work with derived types. And these derived types, they provide specific visualization or behavior. The type that you will mostly work with, that is called a content page. A content page has got a content property, and that content property can hold on to one single piece of content. That can be any visual thing. So our content page can, for instance, hold one button or one label. The next page we have is the master detail page. The master detail page has got two properties. You probably already guessed it. One is called master and the other is called detail. Both of these properties accept the type page. So to a master detail page, you can add 2 pages, for instance, 2 content pages. When your application runs, the master detail page will be rendered differently depending on the platform or form factor that it's running on. So for instance, if you run on an iPhone, it will be a fly out menu or slide in menu or whatever you want to call it. So you can slide that in from the left to the right, or you have the famous hamburger button at the top. If you run the same thing on an iPad, it will use a split view controller. So it will display master and detail at the same time. If you run on Android, you will get a drawer layout. So XamarinForms tries to use the native available UI and APIs whenever possible. And only if necessary, there are custom implementations, like in case of the flyout menu on an iPhone. And I already briefly talked about that. Most applications have multiple screens, so we need a way to navigate between these screens. And a common technique to navigate screens is to use a stack-based navigation. If you want to use stack-based navigation in your XamarinForms application, then you wrap your pages into a navigation page. The navigation page manages a stack of pages. You can push new pages on the stack and you can pop them off the stack again. This works pretty much like UI navigation controller on iOS and also similar to the stack-based navigation that is built into Android. And of course, we also have a tabbed page in XamarinForms for utility or tools applications where each screen is equally important. You want to use this kind of page. Again, you add multiple pages to a tabbed page, and the user can then flip through these pages by pressing the tab buttons at the bottom of the screen on iOS or at the top of the screen on Android. So again, if we run on iOS, this will turn into a UI tab bar controller, and it will use other native UI implementations on the other platforms. So you will get something that looks and feels truly native. And the reason why it does so is because it is truly native. You just happen to describe it in an abstract way with XamarinForms. One thing to note is that just like on iOS, the tabbed page also supports overflow. That means if you keep on adding tabs there until there is no space anymore, then there's a way for the user to navigate to these overflowing tab items. And again, this will use whatever the native platform provides. So on Android, you can scroll, for instance. And finally, we have the carousel page. The carousel page enables swiping left or right to change from one page to another. So like the tabbed page, you add multiple pages to a carousel page. It's got a children property that takes the array of pages, and then you can navigate between them. Typical use case for this is a photo application where the user can swipe through all of the available images. So now we have the first ingredient, the pages. On a page, we can place views. Views are typical controls that you have used in other frameworks, and all the common ones that you would expect from a framework are there. And if one is missing, then you can, of course, create your own. So let's have a look at these. Short overview. We have labels, which give you a read-only UI element. Then we have entry, that is a text field. Also, all the properties that you know and love there, like placeholders, enable it, disable it, and so on. We have buttons. And again, The button you see here on that screenshot, this is an iOS button, so the abstract button will turn into something platform specific. It will look differently on Android and on Windows Phone. We have editor. It's maybe not so obvious. Editor is, well, a text view or a multi-line text field. And then we have different pickers. There are built-in ones for date and time, but you can also use the base picker class, which lets you select something from an arbitrary collection of strings. We also have UI elements like box view and frame, which are either solid rectangles that you can use or, well, borders around something. They support shadows and solid colors and stuff like that. Of course, there's support for images. Images can have local URLs, local files, or remote URLs. We have progress bars, which indicate some ongoing progress. Sliders, steppers for integer values. Sliders, you would use them for, well, decimal values probably. Of course, we have switches, and we also have support for special cases like a search bar that you can include into your application. And sometimes it might be necessary or good to include some HTML contents. Of course, there's a web view. If you want to draw some OpenGL content, well, then you're going to use the OpenGL view. And if you want to display a long list of information, and there's almost no application that won't need that, you can use the list view, and list view can be templated, and this, for instance, turns into a UI table view on iOS, or, well, on Android it's got the same name, it's also a list view there. And there are more. We have more than 40 predefined controls available in Xamarin.Forms. Be sure to check out the online documentation for information about all of these controls. Now let's have a closer look. How does this transformation work from our abstract UI elements into something that is platform specific? So far we heard that the abstract button becomes an iOS button, a UI kit button. But how does that work? Well, the piece of code that does that is called a renderer in Xamarin.Forms. And there is a renderer for each and every control and for every platform. So we have 3 button renderers, for example, one for iOS, one for Android, and one for Windows Phone. Now, if you create this piece of code here and you run it on Android, the platform renderer for Android will be called, and that abstract button will be turned into an Android.widget.button, and the corresponding properties will be set. So the text that is described in the abstraction, click me, will be shown on that Android button. If you run the app on iOS, well, then your abstract button turns into a UI button. Again, there's a platform-specific renderer for iOS that turns that button into a UI button. And of course, we have similar approach for Windows Phone. We have Windows Phone renderers, and they will create system.windows.button elements. And these renderers exist for every control. That's also the reason why we really need the platform-specific projects. We will see that later in code, that in every project there's a reference to a library that is platform-specific, and in there we will have these renderers. So the important thing here is you define your UI once and you share it. But as a result, you will get a native UI on each platform, and that feels just natural to the platform. So this is what is so special about Xamarin.Forms. In the previous example with that button, you have seen that we can set a text property. And just like that text property, there are various properties available for the different control types. We have, for instance, placeholder properties for text fields, where you can give the user a hint what you expect as an input in that field. You can also specify for an entry field, for instance, what kind of keyboard would you like the operating system to provide. So maybe you expect the user here to enter a phone number, then you want a numeric keyboard. You gotta be careful here. Most of these properties, they will do exactly what you expect. But notice that they can be interpreted differently on each platform. So it doesn't mean that they're gonna look the same on all platforms. So it could be that the numeric keyboard on iOS only includes, well, digits, while the numeric keyboard on another platform might also include some sort of punctuation or something like that. So don't expect only specific inputs from one sort of keyboard. You always still have to verify that. The other thing that you have to be careful with is that not all features are supported on all platforms. So for instance, Windows Phone, it dictates a bit more how controls are spaced out and how thick borders are. And so the properties that you set in your shared code, in your Xamarin.Forms code, they might not actually affect the visualization. The visualization will be affected on iOS and on Android, but not on Windows Phone. And there are properties that maybe set some feature on Windows Phone that won't do anything on iOS. So using Xamarin.Forms is not an excuse for testing. You still have to test all your platform-specific projects. Verify that they really do what you expect them to do. In addition to the properties that we have to influence the look and feel, we also have a lot of events that are exposed on our controls. In the example here, we use a text changed event on an entry field. If you subscribe to these events, you can use event handlers as shown here. You can use delegates, lambdas, whatever you prefer. They work just the way you expect them. But now it's time to try Xamarin.Forms out. So we want to switch over to our development environment and create a new Xamarin.Forms application. I'm going to use Visual Studio here today. Here in Visual Studio, we'll use the File, New menu and create a new project. This brings up the templates that are available on the system that you're working on. Scroll a bit down and find the Mobile Apps section. In there, you have 3 available templates. We want to create a Xamarin.Forms application that is based on a portable class library. You also have the option to create a Forms application that is based on the shared project, and you can also create a library that is based on Xamarin.Forms. We're going to create an app that is based on the PCL template, and we're going to put that here in the temp folder, and we want to name it Hello Forms. If you click the OK button, then Visual Studio will create the portable class library, one project for Android, one for iOS, and one for Windows Phone. Remember, on Xamarin Studio on the Mac, you will only get the iOS project and the Android project, but you can add the Windows Phone project later. Let me close these here for a second and also collapse all the created projects. Now let's go through this. Here is our main project. This is the Xamarin.Forms portable class library project that will contain your UI code and also your shared code. Then we have one project per platform, one for Android, one for iOS, and one for Windows Phone. Now before we have a look at the code, let's try to run these projects. We want to start with Windows Phone. Remember, Xamarin.Forms projects create native applications, so it is necessary to run the individual projects. Here we want to right-click Windows Phone and set it as the startup project. I still need to configure my configuration environment here, so let me quickly do that. Go to the Configuration Manager and configure for x86. In this configuration, I want to build Windows Phone. I also want to deploy it, and I want to make sure that my Xamarin.Forms library is also built. While we are here, let's also adjust the others if necessary. I use ARM to build my Android project. So I'm going to remove the build for Windows Phone, and I also want to configure the one for the iPhone. So we always want to make sure that the Forms library is built. We don't need Android here, and I don't want Windows Phone here. And please note that you can keep these other applications here in the build process. However, deployment will just be faster if you only build the necessary platforms. Let's close that, switch to x86, and then we can run the Forms app here on the Windows emulator. The launch screen appears, and here we have our application, which is really just a static label that takes up the complete screen space. Now let's go back to Visual Studio and try the other platforms. Stop debugging here. Set iOS as the startup project. It automatically switched over to iPhone Simulator, and we want to run that on an iPhone 5S. And here we have the iOS version running. And finally, we also want to run the Android version. So set that as a startup project, pick my ARM configuration. And now I want to connect to the Android emulator, the Xamarin Android player over on my Mac. My Visual Studio here is running inside a virtual machine. So let me show you how you can connect to the Android emulator. First, I want to make sure that the Android emulator is running. I have it here. I can click on the gear icon to reveal the device details. The last entry is the IP address of the emulator in the local network. I'm going to remember this IP address and switch back to Visual Studio. In Visual Studio, under Tools, Android, Android ADB command prompt, I can open a command prompt where I can use ADB, which is the Android debugger, to connect to my Xamarin Android player over on the Mac. So I use ADB connect 10.71.34.101. And it says connected to this IP address on port 5555. Now if I go back to Visual Studio and open the drop down here once more, you see that the Nexus 4 phone that I have started up over on the Mac appears here. So let's select that as the target and deploy to it. I can close this here again. And here we have the app that is based on the Xamarin.Forms template on Android. All right, now let's have a look at how this application is constructed. We're going to start with the portable class library up here. If I expand that node and dig a bit further down into the references, I can see that we have two important assemblies here. We have Xamarin.Forms.core. This contains all the core logic of Xamarin.Forms. And we also have a XAML assembly here for Xamarin.Forms. In this introduction to Xamarin.Forms, we will not use any XAML. But if you ever want to add a page that is based on XAML, you will want to keep that assembly referenced here. All right, now let's have a look at the platform-specific projects. We start with Android. Again, I expand that and check the references. Scroll a bit down, And here we again see Xamarin.Forms.xaml. We also see Xamarin.Forms.core. And of course, we see our Hello Forms library linked. This is the one that we have up here. And you might also notice that there's a platform-specific Xamarin.Forms assembly in here. It's Xamarin.Forms Platform Android. This contains everything that allows Xamarin.Forms to turn the abstract UI into something that is Android specific. And we have similar setup on iOS. Again, the reference to our library, the reference to Xamarin.Forms core, to XAML. But here we have a reference to Xamarin.Forms.platform.iOS. And just like on Android, this is required to turn the abstract UI into something that is now iOS specific. We're going to see later how that works. Well, let me collapse that. And we want to investigate Windows Phone a bit here. And again, here in the references, core, XAML, our library, and here the platform-specific Windows Phone 8 assembly. So we have referenced our forms library here from the platform-specific projects. But how do these platform-specific projects connect to our forms application? For that, we have to look in the code behind. And we start here with Windows Phone while it's still open. We have the main page.xaml in here. And in the code behind, if I open that, you'll notice that the main page here on Windows Phone is not a regular page, but instead it is a subclass of Xamarin.Forms.platform.winphone.forms application page. In the main page constructor, we find two things that are very important. The first one is a call to the static Xamarin.Forms init method. This initializes Xamarin.Forms. And the second thing is we have a call to the load application method. This is a platform-specific method that connects the Windows Phone platform to the abstract Xamarin.Forms application. We pass that load application, I can show that here, an instance of Xamarin.Forms application. So we new up our app here. Where is that coming from? Well, this application is now from our portable class library. We find it up here. Here we have app.cs. This is the app class that we new up on Windows Phone. It's a subclass of Xamarin.Forms application. If we look at iOS, we need to open the application delegate file, have a look at finished launching, and again we have our call to Xamarin.Forms init, which initializes Xamarin.Forms, and here's again the load application method. And again we pass it a new app, which is the same abstract application that we have already used over on Windows Phone. And just like on Windows Phone, we also have a specific superclass here. This time our app delegate is not a subclass of UI application delegate, but it's Xamarin.Forms platform iOS forms application delegate. And finally, we want to look at Android. On Android, we have activities. So let's look at the main activity here. Our main activity is of type Xamarin.Forms platform Android forms application activity. And you probably already guessed it. Again, we have the call to init. This time we have to pass a couple of parameters. We need to pass the context along and the bundle. You remember on Windows Phone and on iOS we did not require any parameters, but here on Android we need to pass these two things around. And then the last line is the same as in the other two platform-specific projects, load application and we pass in the new app. Now, what does this app look like? Let me open that here. We're gonna close all other documents. Our abstract forms application is a subclass of the Xamarin.Forms application class, and in its constructor we create our UI. This is a bit nested. We start with a content page. The content page has a content property, and we assign our content to this content property. In this case, the content is a stack layout. We'll discuss later what this is about. The stack layout has a children property, and we only add one child element here, and that is a label. And that label, this is what you have just seen when I ran the app first on the 3 platforms. Now we want to add some functionality here to this app. Instead of the static label, we want to have some button that reacts to clicks. So let's create a button, and a button is just a new button, and we set some properties here. So we want to have a text, click me. And whenever the button is clicked, we want to update its text and increase a counter so the user sees that something happened. So we want to have a counter here, and then we can use the button's clicked event. And here we can use a delegate or a lambda or event method, whatever you prefer. So let's say sender arguments. And what we want to do here is update the button's text. Well, we say it was clicked count times. And let's increase our counter here. And now we want to replace our label with the button. So now our child element is no longer a label, but it is just our button. So again, what happens here, we have our content, we set that to the button, we create a page around our button, and then we assign that to the main page property here of our application. So the application is the entry point to the Xamarin.Forms application, and the application has got a main page property, and this is where we assign our initial page to. And now let's run that. We already have Android here as the target platform, so let's start with that. Here we have our button. If I click it, it works as expected. And I can of course debug here. So I can put breakpoints in here. This all works just like a regular traditional Xamarin application. I can click here, debug is going to break. I can investigate all the variables just like I would in a normal app. Now let's try that on the other platforms. Let's try iOS next. And notice that here on iOS we get a native UI button, and it works just the same. And finally, Windows Phone. Here we have our Windows Phone version. Again, a native Windows Phone button, and if I click it, it works the same as over on Android and on iOS. And now it's time to see how much we remember from the class so far. Let's have a little flash quiz. First question. Xamarin.Forms creates a single binary that can be deployed to Android iOS or Windows Phone. What do you think? Is that true or false? That's false. The idea of Xamarin.Forms is that you will still get platform-specific applications. So you will build an Android app, you deploy that via the Google Play Store, you create an iOS app and you deploy it via the iTunes Store. Next question. You must call blank before using Xamarin.Forms. Was that A, forms.initialize, B, forms.init, C, forms.setup, or D, there's no setup call necessary? And the correct answer here is B, it's forms.init. Next one. To supply the initial page for the application, you must set the blank property. Was that application.firstPage, application.primaryPage, application.mainPage, or application.mainView? And the answer here is C, application.mainPage. Let's quickly review. We have learned about how Xamarin.Forms works, that it's an abstraction of the UI that will turn into something platform-specific on each platform. We have seen the Xamarin.Forms project structure, and we have one shared project and one project per platform. And with that knowledge, we created our first Hello Forms application and ran it on iOS, Android, and Windows Phone. The previous exercise we did together, and the result was this Hello Xamarin.Forms. In the next exercise, you will be creating an application on your own. This time with a real purpose. And if you have gone through the iOS 101 or Android 101 classes, then you probably remember the PhoneWord application that we created there. This was the very first iOS and Android applications you were dealing with. We want to recreate that app, but this time we're going to use Xamarin.Forms. We have several goals in doing this. First, the PhoneWord application gives us an opportunity to use more controls. So far, we have only seen a static label on the screen and then a button. So we want to see how the layout system works. We will also get a chance to use some of the cross-platform APIs, specifically ones to display an alert, a message box to the user. Before we get into the code, let's talk about the concepts that you need regarding the layout. If you remember the content page, it had a content property. That content property allowed for a single piece of content to be displayed. That doesn't help a lot. Who wants an app with only one button on the screen? But what we haven't talked about so far is the type of this property. You can assign a visual element to this property. And this visual element can be a regular control, like a label, like a button, but it can also be a layout container. And in Xamarin.Forms, much like in Android and in Windows Phone with XAML, we manage layouts with different layout containers. and we select the container based on how we want the content to be organized visually. And if then we want to add child elements to our layout, we use the children property of the layouts. We keep adding these child elements, and the layout container will be responsible for aligning them properly on the screen. This provides a very flexible system, and it's much better than the coordinate-based old layout style that you might have used on iOS. XamarinForms ships with different layout containers. Again, if one of the layouts is not the right for you, then you can create your own. But now let's focus on the ones that are built in. The one that's very often used is the stack layout. You might know stack layout as linear layout from Android. The idea of stack layout is that it places children top to bottom, this is the default behavior, or left to right. And you can influence that by setting the orientation property. And then we have the absolute layout. If you remember, I just said that the layout system is much more flexible than the coordinate-based system that we had on iOS back then. Well, if you want to, you can use absolute layout to use absolute coordinates. However, absolute layout has a very, very nice feature. It allows proportional coordinates. With proportional coordinates, your screen width or your screen size goes from 0 to 1 in width and 0 to 1 for the height. That means if you say, I want my button to be at position 0.5, 0.5, it will be in the middle of the screen, no matter what your screen resolution is. If you want it top left, it will be 0, 0. If you want it bottom right, it will be 1, 1. So you can position the child elements absolutely, but you don't necessarily have to know the real coordinates. And this is certainly a nice feature. Next, we have the relative layout. With that container, you can define the position and size for each child element by specifying relationships. You can either position an element relative to another element or relative to the parent container. And the position and sizes are calculated at runtime using delegates. And you must provide these delegates in your code. If you have already attended iOS 300 here at Xamarin University, which talks about auto layout and constraints, then this might sound familiar. The idea behind this is the same. You define constraints in your code, and from these constraints, XamarinForms calculates where and how to place the child elements. And then we have the grid. The grid is a very, very flexible layout. And I was a web developer back in the 90s, and back then, if we wanted to lay out something in the browser, we were using a table tag. And if you nested 30 table tags back then in the 90s, you were a hero. That was okay. Well, don't do it anymore these days. Now, the grid in XamarinForms behaves pretty much like the table in HTML. The difference, however, is we encourage you to use grid for layout purposes. That's what it was made for, and that's how it's different from its HTML counterpart. And the last container that we discuss here is the scroll view. That's a bit of a special container. The idea is that you can wrap a scroll view around any of the other layouts. If the content becomes larger than the available screen estate, then the scroll view will allow XamarinForms to scroll the content. both vertically and horizontally. If you want to add or remove views to a layout container, then you insert or remove them from the children collection. That's a property that's available on each layout container, and you can add and remove elements at runtime. Notice that it matters in what order you add the child elements here. So for instance, if we take that stack layout here, we add a label and a name entry. The label will be at the top and the name entry will below. If we switch the stack layout to horizontal orientation, the label will be at the left and the name entry will be to the right of it. The stack layout is probably the one that's mostly used in Xamarin.Forms applications, just like the linear layout on Android. So we want to talk about it a bit more. It organizes its content in one of two ways. So either it stacks the child views top to bottom vertically, which is the default behavior, or left to right, or also horizontally. And you can influence that by setting the orientation property. This is an enumeration that contains horizontal and vertical as available values. Now, what about spacing? If we just add child elements into a stack layout, they will probably be stacked on top of each other. So we want to provide some spacing between them. And we have different options here. One thing that is important, child elements cannot set their size directly. They can request certain dimensions. We're going to talk about that in a second. Here we have a couple of properties that are available on different views. So we're going to start with the vertical and the horizontal options. With these two, you define how child content is stretched. That's available on any view type, but mostly you will use that on layout containers. Then we have spacing. Spacing is what gets added between child elements. So if you have a stack layout and you have two buttons in there, then you provide a spacing of 10, you will get a space of 10 units between the two buttons. The space above the button and the space below the second button will not be influenced. If you want to change that, then we have padding. Padding is what will be set around an element. That's available on any page type, and usually you set that to inset the page. So coming back to the width and height. We cannot directly set width and height. If you check the properties of the UI elements, you will find a width and height property. However, these are read-only. These are the final calculated sizes that an element will have. The same is true for the bounce property. The bounce property is the position of the element relative to its parent, and it also contains the size. You cannot modify them. If you want to influence the dimensions of a control, you can set the width request and the height request. So in your stack layout, for instance, you can say, I would like my control to be 200 units wide and 30 units high. And the layout tries to fulfill your request. However, there's no guarantee that that's going to happen. You can also specify a minimum width and height request. You can say, well, if the 200 times 30 doesn't work, then please give me at least 100 times 20 or something like that. And the layout containers, they try to respect these requests as far as possible. Here we have an overview how layouting works. It's based on the CSS box model, but currently we do not have a margin value. So we see the spacing is what is used between child elements, and the padding is used around the elements. And each element has a width and a height, but these cannot be set directly. Instead, they request a width using the width request and the height request properties. What is worth noting? We are running on different platforms, and different platforms have different, well, screen sizes and different ways of describing the amount of pixels that are on a screen. So the old iOS devices, they had 320 times 480 pixels. Then the Retina displays arrived, and suddenly we had 640 times 960. And Apple then no longer talked about pixels, they have virtual units. 2 of these units was 1 pixel. Now on Android we have, for instance, device-independent pixels, DIPs. What's Xamarin.Forms doing with that? What happens if you say, I want a spacing of 10? What is this? And the answer is, it is what it is on the platform. So if you specify a spacing of 10 and you run on a Retina device on iOS, it will be 10 virtual units. If you run the applications over on Android, it will be 10 device-independent pixels. So it is what it is on the platform. Again, that means you have to test on all platforms to know what it's going to look like. And with this, you have enough information to work on the PhoneWord application on your own. So we're going to switch over to the exercise instructions and go through them before we start. Please go to the class materials and open the Start Here HTML file. In there, you will find an overview over this lecture. You also have access to all of the slides that we have here in this class, an overview of the objectives, and down there you will find the exercises that you'll be working on today. We have already covered the first one, which was creating a Xamarin.Forms application. That's what we did together in the first group exercise. The second exercise is an individual exercise where you will recreate the PhoneWord application as a Xamarin.Forms app. Well, let's go ahead and have a look at the exercise. The duration for this exercise is 20 minutes. And the goal will be to create a Xamarin.Forms app that looks something like this. You have a label at the top, an entry field for what's called a phone word, a translate button to translate the phone word into a real number, and a call button. We will start by creating the UI. To replicate that UI, you'll best use a stack layout with a label, an entry field, and 2 button elements. In order to respond to the click events of the buttons, subscribe to the exposed event handlers, and when the translate button is clicked, access the text property of the entry field and retrieve that and use it to convert it over into a traditional phone number. Don't worry, you don't have to program the logic that translates a phone word into a real number. In the assets folder, you will find the phoneTranslator.cs file. I'm going to open that up for you here in the Finder. So in the Part 02 resources, we have the phoneTranslator.cs. I'll quickly open that here in a text editor. This is a static class that contains one method which is called toNumber. And you pass it a raw string and it will return you another string. This will be the converted number. So just include this class into your project and then make use of it. Down here, you find all the individual steps that you need to complete this exercise. It all starts with creating the XamarinForms application, adding the required files, and all the way down creating the UI and the logic. Please note that you do not need to implement the part where the number really gets dialed. This is something that we will save for the upcoming exercise. As a final note, here's something that you might want to use. It's the device on platform call. We're going to talk about that later, a bit more detail. But device on platform lets you execute an operation on a specific platform. And here in this example, you will want to use that to change the insets for the iOS applications a bit. The problem on iOS is that the status bar is considered a part of your UI. So by default, it would overlap with your UI. If you want to make sure that your UI is not overlapped by the status bar, you have to specify a bit of a higher inset. So by using 20 on iOS, you are right below the status bar, and by using 40, you're 20 units away from the status bar. Let's quickly recap the first individual exercise. I'm going to switch over to Visual Studio, and I have the completed solution open here. And we want to run it quickly on Windows Phone. It's already up to see what it looks like. So here we have the Windows Phone emulator. We have our label up here. We have the entry field below. I can enter a phone word here. If I click the translate button, the text of the call button will change and it will reflect the translated number. If I click the call button, nothing happens. We have not implemented that functionality yet. That will happen in the next exercise. Now let me go back here to Visual Studio, and we want to walk through the code quickly. We do not need to look at the project-specific implementations because nothing has been changed there. All the changes are inside our phone word portable project. First, notice that we have added the phone translator CS here. This is the class with the static method that translates a phone word into a real number. If we look at our app CS here, it's pretty empty. All we do is we set our main page property to a new main page. This main page is a class that we added here to the application, and it is a subclass of content page. Now this is something you will see in many XamarinForms applications. It makes sense to have one file per screen or per page, and for each of these you're gonna subclass content page. And this allows you to easily maintain your application, because then it's really easy to spot the individual pages in your app. Now to the code. We have all the UI elements in here. We have an entry element for our phone number. We have a button to translate the phone number, another button to call it, which is not used yet, and we have a string that will hold the translated number. In the constructor of our page, we set up some device-specific padding. On iOS, we want to have a bigger inset at the top, so we use the device.onPlatform here, and we say on iOS we want to have 40 units from the top, and on the other platforms we only want 20. And to the left, the right, and at the bottom, we always want the same value on all platforms. Then we create our stack layout. We set its options to fill the entire screen. So I want that to fill and expand vertically and horizontally. We set its orientation to be vertical, so we want our elements to be aligned top to bottom. We set a spacing of 15. Remember, spacing that was between our child elements. And next we start adding the individual controls. So we create a new label here, which is static content for our phone word text. Then we add an entry field. We add a translate button. And we add our call button down here. And remember, it matters in what order you add these elements to the children collection. Finally, we want to assign an event handler here to the clicked event of the translate button. In there, we use the static method of that class that we added to the project to translate the number. We grab the phone word from the phone number text entry field by using the text property. We pass that into the translated number class member variable. And then we enable or disable the call button depending on the result of the number translation. So if we have a valid number, we enable our call button, and we also want to update the text to say call plus the translated number. All right, let's have another flash quiz. The direction left to right or top to bottom of a stack layout is organized and controlled by which property? Was that A, style, B, direction, C, orientation, or D, layout direction? And the correct answer here is C, orientation. You can set the orientation to be either vertical or horizontal. Next one. Which of these controls is not available in Xamarin.Forms? Is that A, the button, B, date picker, C, list box, or D, list view? And the correct answer is again C, that's list box. Buttons are available. Date picker is a subclass of the general picker class. Then we have a list view, which is kind of a table view on iOS, but list box is not available. Next one. To adjust spacing between children when using the stack layout container, we can change the blank property. What do we use to adjust the spacing between children? Is that A, margin, B, padding, or C, spacing? If in doubt, pick C. Again, C is the right answer. Spacing, that's what we use to describe how much space we want between child elements. Padding is used around the whole stack layout, and margin is currently not available in Xamarin.Forms. In this second part, we covered layout containers, because we had the problem that a content page can only hold onto exactly one UI element. But if we make that one UI element a layout container, we can add multiple child elements to the layout. And this allows us to have pretty sophisticated UI on all platforms. If you think back to the previous exercise for a minute, you parsed the text that is in the entry field and you turned that into a real phone number, and you probably updated the text property of the call button with that real phone number. However, dialing that number was not functional yet. The problem is that to dial a number, we will need platform-specific functionality. Now, Xamarin.Forms is a cross-platform API. It doesn't really know about something that is platform-specific. So we have to talk about this a bit. There are three things we'll be looking here. First, we can customize the UI per platform in our shared code. You have already seen that a bit in the previous example. Second, we can use some of the built-in platform features that are directly exposed to XamarinForms. This includes things like showing a message box, as you can see here in this screenshot. And finally, for those things that are not directly available in XamarinForms, we need to find a way to call platform-specific code. And in order to do that, we'll be using the dependency service which ships with the XamarinForms. Let's quickly recall the XamarinForms architecture. Each of our apps is made from two components. We have shared code, that is in a portable class library. In there we find our UI and we find our business logic. And then we have at least one platform-specific project. These are the actual applications that we will deploy. Now, the PCL is a great thing because it allows us to, well, share the code across all platforms. But unfortunately, it's got significant limitations in terms of the APIs that we can use. In particular, there are many platform features that make iOS, Android, and Windows Phone great and unique, but they are unavailable to us in a portable class library. However, these features are available in the platform-specific projects. So we can use them. We can write this code in the platform-specific project. But the question is, how do we make the XamarinForms portable class library project aware of these platform-specific code snippets that we have there? And the first thing that we want to look at is using the built-in API that XamarinForms gives us to tweak things a bit depending on the platforms. We have, for instance, the device.onPlatform method, which allows us to execute code depending on the platform we're currently running on. The device.onPlatform method takes 4 delegate methods, one for each platform. You'll also notice that there's a fourth one, which is the default delegate. What you can do here is, you can, for instance, say, if we are running on iOS, execute a different code branch in our shared code. If on Android, execute yet another bit of code. And by default, execute something else. So all of these 4 parameters are optional. And I recommend you use this schema to use them. So really specify the parameter name followed by a colon to indicate what you're trying to achieve. Note that this does not allow you to execute something that is available on iOS only, so some iOS specific API or some Android specific API. We are still limited to shared code. However, we can execute different parts of our shared code depending on the platform that we're currently running on. There is a second version of device.onPlatform, and that's a generic. It's device.onPlatform.t. And this one takes 3 parameters and all of them are mandatory, so you cannot omit them. And the 3 parameters, they correspond in this order to iOS, Android, and Windows Phone. There isn't a default parameter case here. You must supply all 3 values. So that method is useful if you want to change a parameter or a property based on the platform you happen to be running on. In this example here, we adjust the top of the thickness class based on the iOS platform. So remember, before we started the exercise, I said that on iOS the status bar is part of your UI. And this means you are responsible for taking care of creating the correct insets for your UI, so the status bar won't overlap your UI elements. So what we did in the exercise was we used device.onPlatform to generate a higher top inset for iOS. And that's exactly what's happening here. We say we want 5 units everywhere, except on iOS we want 20 at the top, and on the other platforms we want 0 at the top. And let me point this out once more. The important thing is we put all of this in our shared code, but we make it execute a specific branch or return a specific value based on the platform we are executing on at runtime. We cannot access platform-specific API with these methods. Alternatively, what we can use is the device.idiom property. Device idiom tells you what form factor am I running on and what operating system am I currently on. So if you add a check like this one, you check am I on a tablet and am I on iOS, that means I must be on an iPad. Once more, this does not allow for platform-specific code to be executed either. We're still limited to the shared logic. XamarinForms has support for a couple of other useful features. For instance, there is device.openURL. You can use that to open any URI using the platform-specific handler. So on iOS, this will open Safari. Then we have page.displayAlert, and you can use that to show simple 2-button modal message boxes. On iOS, this will use a UI alert view or a UI alert controller. On Android, this will use a dialog. On a Windows Phone, it will use a message box. Please note that this is not a static method. The display alert is a member of the page base class. So it's not a static page.displayAlert. In your page, it will be this.displayAlert, just to avoid confusion. Then we have device start timer. That allows you to create a timer independently from the platform you're currently on. If you want to stop the timer, you pass in a delegate and you return false from the delegate, and the timer will be disposed. If you want to create your own threads and you need to marshal back to the UI thread, then you can use device.begin invoke on main thread. That allows you to update the UI. And finally, we also have support for cross-platform mapping. And this is achieved by adding the Xamarin.Forms.maps component. And you can find that on NuGet. With that, you have abstraction of the Google, Apple, and Microsoft mapping API, and you can run maps cross-platform. You see, XamarinForms already has some really powerful and useful APIs built in that allow you to, well, make use of some of the platform-specific APIs. However, it is very likely that there will be some feature that is not available to your shared code. And for all of these cases, we have to put a little architectural thought into our app. If we want to be able to invoke something that is specific to a platform, then we somehow have to make that code available to the shared code in our portable class library. So let's explore a bit what XamarinForms has to offer here to support us. But please note that we can only cover the basics here. Cross-platform programming is such a big topic that we have two classes here at Xamarin University. We have the Introduction to Cross-Platform Development in Xamarin 110, and we have XAM 300 for more advanced cases. Be sure to attend those. The key principle that we will always apply if we want to invoke platform-specific APIs is abstraction. What we do, we will usually create some sort of interface. Coming back to our example of the phone word application, we want to dial a number. So we create an interface. This is our contract. This is our promise. And this promise says that at runtime, there will be a method make call where we can pass in a number, and the make call method will return true if the call succeeded, or it will return false if the call failed. Our shared code defines that iDialer interface, and all the code will be programmed against this interface. And we just say that at runtime there will be an implementation of this interface available on iOS, on Android, or on Windows Phone. In the platform-specific projects, we then implement this interface by using whatever is available on the platform to fulfill that request to place a call. And we'll see that the implementations are quite different on iOS, Android, and Windows Phone 8. So in our shared code, we have this interface, our contract. And in the platform-specific projects, we have the implementations. That's certainly nice. But how does the shared code know which specific platform implementation it is supposed to call? Today, we want to use the dependency service, which is an implementation of a service locator pattern in Xamarin.Forms. Alternatively, you could use the messaging center, which is also built into Xamarin.Forms. The idea of a messaging center is that you publish messages and you have subscribers, and you will use that if your components are very loosely coupled. But like I said, let's focus on the dependency service for now. This is a multi-step process that we're going to do here. The first step is to define our abstraction as already discussed. We have our iDialer interface in that case. Again, this must be in the shared code. Why? Because all parties require that interface. The shared code will be implemented against this interface. And the platform-specific projects, they want to create concrete implementations of this interface. So let's define that in our portable class library. Next, for each platform-specific project, we will have implementations of this interface. So we'll have a phone dialer iOS, a phone dialer Android, and a phone dialer Windows Phone. And one thing that is important here, you might notice it. This class, this platform-specific implementation, does not need to be public. External users will not know about the class directly. They will only ever reference it via the iDialer abstraction. Once we have the implementations in place, we must somehow advertise it. We must inform Xamarin.Forms saying, this is our implementation of a specific interface. In order to do that, we use the dependency attribute. And we add this attribute at assembly level in our platform-specific code. So we use assembly : dependency, and then we specify the type of the implementation. Here on iOS, that would be phone dialer iOS. On Android, it would be phone dialer Android. Alternatively, you can also use a new register method. That allows you to add specific instances or types to the dependency service in code versus doing it declaratively here with an attribute. What this will allow you to do is to make runtime decisions. So for instance, you could have cases where you say, maybe on iPad, I want a different phone dialer than on iPhone, and I can decide at runtime which one I'm going to use. Today, we're going to stick with the attributes and use those. Once we have decorated our platform-specific implementation with that attribute, we can then use the dependency service in our shared code to request the abstraction. And we use the static get method of the dependency service, and as a type parameter, we pass in the interface that we want to get resolved. In our case, this would be iDialer. What then happens is that XamarinForms will look through all the classes that were decorated with the dependency attribute and implement iDialer. And from all of these, it will pick the first one and return it. If it gets returned, then we can go ahead and interact with it. So in our case, we could check, is the dialer not null? And if it is not null, then we can call dialer.makeCall and check the return value. And with that knowledge, we're gonna move back to the lab materials and have a look at the last exercise where we want to complete our phone word application and add in some dialing logic. In the lab materials, please open exercise 3, adding support for dialing the phone. Our application won't change a lot. What we want to do is, when the user clicks the call button, we want to bring up a little message box asking whether he really wants to dial that number. If no, the dialog will be dismissed. If yes, then we want to trigger a platform-specific implementation to dial that number. Like in the previous exercise, you will find a couple of assets in the Part 03 resources folder that you can use to complete your application. Just include them into your project, and you can either use the start solution from the Part 03 resources folder, or you continue with the solution that you have already open from the previous exercise. Here's an overview of what we want to achieve. First, we want to add an event handler for the call button that will do all the logic. The handler will then bring up the message box asking dial that number, yes or no. If yes, then we want to make use of the newly defined interface iDialer. Use the dependency service to locate the implementation of this iDialer interface. Place the call, check if it was handled correctly, and please note that this will only work on real devices. On iOS, if you try to place a phone call, it will always return false. On Android, it will simulate the call, and the same will happen on Windows Phone. However, it will never make a real phone call. So it's best to test that on a physical device. We first want to add some behavior to the call button. And to prompt the user, you can use the display alert method. And again, remember, this is not a static method, but it's your content page .display alert. If the user confirms this dialog with yes, then you want to get the platform-specific logic to dial the phone number and make use of the make call interface method. And finally, there's something that is important for Android and Windows Phone. You have to have specific permissions to place calls on these platforms. So be sure to open the Android application settings and tick the call phone permission down here. On Windows Phone, go to the Capabilities tab in the settings and select the ID cap phone dialer permission. And finally, you can test your application, use the dependency service, add the dependency attribute, and try to place that call. All right, let's recap the second exercise. Switching over to Visual Studio, and I have already opened the completed solution and I'm running it here on the Windows Phone emulator. So again, the same UI, which we already know. I can now click the Translate button, the number will be translated, and if I click the Call button, I'm going to show that message box. I will ask the user whether they really want to dial that number. If I click No, I go back to my UI. I'm going to open it again. This time I confirm, and this will trigger the method in our dialer interface. Now here on Windows Phone, we have the behavior that Windows Phone asks the user once more. So here on Windows Phone, we already have a confirmation dialog. So we got 2. This would maybe be a good situation to use the device on platform and skip our internal jack when we are on Windows Phone. But for now, let's just continue and say we want to place that call. And you see Windows Phone really simulates the call. It says now we are connected to that number. And if we end the call, we will go back to our app. Now let's look at the code. In our shared code, we have added the iDialer interface. Really simple, just one dial method, which takes a number and returns a bool that indicates if the call has succeeded or not. On our platforms, we have implementations of this interface. So here on Windows Phone, we have the phone dialer.winphone.cs, and you see it's implementing iDialer, and it's using the Windows Phone phone call task API to place the call. Up here, you see the assembly attribute that defines the dependency for the XamarinForms dependency service. So here we register the type phone dialer, and because that phone dialer implements the iDialer interface, we can later resolve that in our shared code. We have similar implementations for the other platforms, so let's quickly look at them. Here on iOS, it's just calling UIApplication.SharedApplication.OpenURL. And again, we are subclassing iDialer, we implement that interface, and we register the dependency. On Android, same attribute, same interface, but different implementation. Here we create an intent, we use the action call intent, and then we use the context to start an activity based on that intent. Now what is interesting here is the fact that how do we get access to the current Android context? After all, this code is triggered from our XamarinForms app. The nice thing is that XamarinForms provides a static context property in the forms namespace. And this allows us to always get to the current context here on Android, and we can use that to start our activity. Now let's have a look at our main page where all of this is used, and we want to focus on the onCall method here. That gets triggered if the call button is pressed. We use display alert to show a message box, and we ask, would you like to call the translated number? We have a confirmation button and a cancel button text. And notice that we can await this. This is an asynchronous method. Because our onCall method is decorated with async, this will enable the await keyword inside that method. So here we can simply await this asynchronous method, and if it returns true, then we use the dependency services get method and try to resolve the iDialer interface here. And if resolving that succeeds, we get back a dialer object, and then we call the dial method, pass it the translated number, and then it will go into the platform-specific code. Let's recap this last part. We saw how we can tweak and influence the UI per platform by using the device.onPlatform methods or by checking the device idioms or the operating system that we're currently running on. This, however, did not allow us to execute platform-specific APIs. In order to achieve that, we introduced the dependency service. With the dependency service, it is easy to register platform-specific code and to resolve these dependencies at runtime by using the dependency service.get method in your shared code. And with interfaces, we are able to call out two platform-specific methods. And with that, we are at the end of this XAM120 class, Introduction to Xamarin.Forms. I really hope you enjoyed it, and see you again soon. Thank you for watching.